Alright, let's get started with the second topic under Research Aptitude, which is Research Process. So I've completed this part and mostly focused on these. If you've done types of research, then quantitative and qualitative research is just a topic under it, which you can easily do on your own and through notes, which you'll get in spaced revision. Today I'll be focusing on research process. From steps in research, not a lot of questions are expected from. The only questions I have seen is mostly around review of literature and what are the best ways or the best practices to do review of literature, or what are the steps to do review of literature. So mostly questions surrounding these, and they're not very difficult. It's pretty intuitive to answer these. Even the different steps, the hierarchical process in steps are pretty intuitive. So the ones that do require a lot of notes, a lot of theory are variables, scales, different softwares in research such as SPSS, Stata or Turnitin, and biases in research, which I'll be tackling in this particular video. So let's get started. First are variables, and we're gonna be doing different types of variables. And you can expect direct questions from these, mostly in the form of match the following. So you'll be given different types of variables, different definitions, and you might have to mix and match to see what definition fits what variable. So let's get started. First is categorical variable. A categorical variable is a type of variable that can take on limited or fixed number of values or categories, such as yes or no, gender, male, female, or other. We have colors, red, blue, green. So pretty easy. There are three types of categorical variable. One is constant variable with only one and no variety. Second is dichotomous variable. It's like two choices, yes or no. And third is polytomous variable, which has more than two categories. Mostly in Likert scale, if you've taken any survey, you've seen 5 is most likely, and then 1 is least likely, and then you have to assess somewhere in between, maybe 3 neutral. So those are polytomous variables. Next we have independent and dependent variable. Probably some of the most confusing if you are beginning at research, but also some of the most important topics, and a lot of questions get asked from these. So make sure you understand what is independent variable and what is dependent variable. The kind of questions you can expect is you need to identify which is what. So let's understand them independently. Independent variable is a variable that is manipulated or changed by the researcher. It is a variable that is hypothesized to cause an effect on the dependent variable. Okay, so imagine you're doing a regression, any multiple regression, any type of regression. So first you have, let's say, the dependent variable, the variable that you are looking at, what's causing it, and then you have multiple independent variables. You want to see the effect of these variables, which is caused by either you changing it or natural causes that is affecting the dependent variable. So a dependent variable is the variable that is measured or observed to assess the effect of the independent variable. Okay, it is a variable that is expected to change in response to changes in independent variable. Let's take an example. Let's say you want to assess how much water will affect my plant growth. So what do? You take different water amounts, let's say 5 liters, 25 liters someday, 10 liters, 7 liters, whatever, okay, depending on how you feel. This is definitely taken based on some theory, but right now I'm just taking random figures. And then you see the plant growth, which is your dependent variable. So if I put 5 liter of water, how much plant growth will I receive? If I put 25, how much is it? If I put 10, how much is it? So what are you doing? Based on these changes, you are looking at the changes in dependent variable. So independent variable are either manipulated or changed based on natural causes, and dependent variable is a variable that you are observing the changes in, and creating a cause and effect analysis. Okay? So hope you understood. It's not very difficult. You do MCQs 2-3 times, you read this 2-3 times, you'll get a hang of it. Next we have intervening variable. An intervening variable is known as a mediating variable or variable that comes between the independent and the dependent variable in a causal chain. It explains how or why the independent variable affects the dependent variable. Let's take an example to understand this. If I were to say that let's take different individuals here. Here we have Sonam, here we have Ayush, here we have Priya, here we have Rushali. So we have 4 different individuals. Now as a researcher, I've realized Rushali's spending is quite high. And I've also realized Ayush is also quite high. And these two people, their spending is quite low. So I kind of make an hypothesis that both Ayush and Rushali are postgraduates, so that's why their spending is more. So now I'm trying to make an assessment that because of the level of education, their spending is increasing or decreasing. And why is it happening? It's happening because of income level. So more education you get, more is your income level and more is your spending. And it's pretty basic, right? The more you earn, the more you want to spend. So what is the cause behind the relationship that level of education and spending is showing? It is the income level. So this is intervening variable. Next, extraneous variable. They are like the uninvited guest to the party. So, kebab mein haddi. An extraneous variable, also known as confounding variable, okay, be very wary of the different terms under it, also known as, because again, UGC loves playing with key terms, and that's been my dialogue throughout this course. They love playing with key terms, and they're gonna use the most complicated term to define a very simple word. So you need to be aware of the different key terms that are there. So an extraneous variable, also known as confounding variable, is any variable other than the independent variable that can affect the dependent variable. And because of this very reason, we have random errors, we have systematic errors. These variables can potentially introduce error or bias into the result of an experiment if they are not controlled or accounted for. So in this particular case, an extraneous variable could be family wealth, which could offset the entire research. Next we have active variable. An active variable is a variable in an experiment that is deliberately manipulated by the researcher to observe its effect on another variable, mostly used with experimental research. It is like having the remote control to change the channels, the amount of fertilizers applied to the plant. The researcher might assign different doses to see what affects what. So you may be questioning, but independent variable was also that only. So active variable would be a sub part of independent variable. So let's say this is independent variable, this would be active variable. So all active variables are independent variables, but not all independent variables are active variables, because independent variables can also exist naturally. Natural changes like changes in age, where the researcher is not manipulating. And active variables are variables that researchers are manipulating. Next we have attribute variable. These are hands off. It means that something that should not be touched or interfered. Again, mostly with experimental research, we can't change them, control them, or manipulate them at our will. They are what they are, like our age and gender. So in a study of memory and age would be the attribute variable. The researcher wouldn't change the participant's age, but they would observe how age affects memory. Next we have continuous variable, and the opposite of that, discrete variable. And continuous variable is a variable that takes on any value with a specific range. These variables can be measured with precision and have fractional values as well, not just whole numbers. And discrete variables are basically whole numbers, such as height, weight, temperature, time, and for discrete variables, number of students in a classroom, number of cars in a parking lot. Next, we have confounding variables. A confounding variable is a type of variable that influences both the independent and dependent variable in a study, making it difficult to determine the true relationship between two variables of interest. For example, let's say you want to do an experiment where you want to see vitamin C supplements like lemon water has an effect on prevention of cold. Now let's say you came up with a positive correlation that drinking more lemon water has a positive relationship with prevention of cold. So if you take more lemon water, then you have less cold. Okay? But what can happen is also that people who take vitamin C in general may be more healthy otherwise. Like they may take regular exercise, balanced diets, which could also prevent cold. That's why your whole research can negate the entire factor because of confounding variables. Next, we have another very important term in research, and this is taught throughout Masters UG, scales in research. We have four different types of scales of measurement: nominal, ordinal, interval, and ratio. Nominal scale is a scale of measurement that categorizes data into two distinct or more groups without any specific order or ranking among these categories, such as male female. You have no ranking, right? You can put one above the other, it's just a choice. Next, we have marital status like single, married, divorced. There is no ranking that single is better than married or married is better than divorce. It's just, it is what it is. So nominal scale is just a level of measurement that categorizes data into distinct categories. Nominal scale in itself doesn't hold any value. It's valueless. Next, we have ordinal scale. It is a type of measurement system used to rank. Now value is coming into picture. It tells you the relative strength of something but not the exact difference between them, such as Likert scale. Very dissatisfied to satisfied. You know satisfied is better than dissatisfied, but you don't know by how much better satisfied is more than dissatisfied. It could be 10 times. It's qualitative, it's subjective, right? So that is ordinal scale. Although we know the rank, but we don't know the exact strength, the ratio, the interval between two different variables under ordinal scale. Next, we have interval scale. It's a measurement that builds on the strength of the ordinal scale and adds another crucial value, which is equal intervals. For example, like ordinal scale, interval scale establishes a clear order ranking. You can say what is higher, what is lower. Let's start from here: 0, 1, 2, 3, 4. So we know 4 is more than 0, or -1, -2, -3. And we also know the strength. This is 1, this is 2, this is a difference of 1 each side. But unlike ratio scale, and that's where the difference lies between ratio scale, that 0 is often arbitrary and does not represent a complete absence of quantity being measured. For example, 0 degree on Celsius scale doesn't represent a complete absence of heat. It's just a reference point. So because of this, you cannot make a meaningful statement about ratios. For example, let's say you have 0, you have 10 degrees here, you have -10 degrees here, you have 20 degrees here. You cannot say that 20 degree is twice as hot as 10 degree because 0 holds absolutely no value. Let me give you another example because I understand that it can be tricky. When you're measuring weight, you know 0 kg means 0. Alright, it's weightless, right? But 0 degree doesn't mean there's no temperature. It's just a reference point towards higher temperature and lower temperature. So this deficit is completed by the ratio scale. It is the most precise and informative measurement system among the four common scale. It builds on the strength of interval scales. It has a 0 value and adds a crucial element, a true 0 point. Let's come to softwares in research. And this is probably one of the most important topic, because in the recent trend, if you see, there are a lot of questions asked from softwares and research, especially in the 2023 December and June shift. Under reference management software, we have EndNote, Reference Manager, Mendeley, which is probably one of the most common reference management software. You can download a desktop copy and it takes care of all your references. I would simply use the inbuilt in Word for my references. Next, we have plagiarism detection software, Drillbit and URQuint. UGC recommends the use of Drillbit and they both come under InfilbNet. I think Turnitin is probably one of the most common and the most popular plagiarism detection software and used across universities all over the world and in India. And we have data analysis software, another super important topic. First, we have SPSS, Statistical Package for the Social Science. It is known for its easy to use interface and helps in descriptive and inferential statistics and regression analysis as well. Next, we have Minitab. It is used for a lot of panel regressions, time series regressions. We have MATLAB used for numerical computation, data analysis, and visualization. We have Tableau, again used for visualization. A lot of data analysis firms use Tableau. We have Stata, used for data analysis, including tables, charts, built-in statistical features, and mostly used for its powerful graphical capabilities and strong data management features. And we have Excel, where you can do inferential regression or descriptive statistics with ease. Next, another very important topic, biases in research. As researchers, we need to be aware of the biases so that we don't cloud our judgment when conducting research. And because biases are so psychological, sometimes we don't even realize when we are biased and when we are doing something. So we need to at least learn about the different biases to even be aware of the fact that we can make these errors. Because it happens in a very subconscious manner. So first is selection bias. Occurs when the sample used in a study is not representative of the population intended to be analyzed, often due to method of selection. So as a researcher, you tend to select the sample based on the study that you are doing and fits best for the study. So here's a cartoon to depict exactly that, and I'm very fond of cartoons. We received 500 responses and found that people love responding to surveys. Obviously, people who don't love, which could be more than 500, didn't even read them, right? So sampling bias. Under selection bias, we have sampling bias when certain groups are overrepresented or underrepresented. Attrition bias when participants drop out of study leading to non-representative sample. Impact can lead to inaccurate or non-generalizable results. Next, we have confirmation bias, and this is probably one of the most interesting bias and happens so quickly that you don't even tend to realize, because your brain kind of functions this way. The tendency to search for, interpret, or remember information in a way that conforms to one's perception or hypothesis. And again, another comic to represent confirmation bias. It leads to selective reporting and distorted conclusions as contradictory evidence is overlooked. Really understand what confirmation bias tells you, and you can apply this throughout your life in multiple areas of your life. This is a really interesting bias in behavioral science. So, as a researcher, when you're doing review of literature or when you're trying to find evidences for your study, if you click only on the links that fit your study, then you're conducting a confirmation bias. Observer bias occurs when the researcher's expectation and knowledge influence their observations or recording of data. So imagine as a researcher you have to take survey or you have to take certain interviews, and you've already formed a hypothesis in your brain that this has to be correct. So even when you're interpreting data or when you're collecting data, you tend to take data that is aligning with your personal beliefs and aligning with your research topic. So Howard's anxiety level, the price of peanut butter. So you kind of form a very funny correlation between the two and say that my anxiety level is probably related to the price of peanut butter, but it can just be correlation and there's no causation to that. Next, we have response bias arises when participants provide inaccurate or untruthful answer due to various factors like social desirability, leading to distorted results. And these happens a lot with social science research, especially around villages where it's a taboo to talk about marriage, love marriage. If you're doing any research around love marriage or if you're doing any research around rape victims, then you get a lot of response bias. Impact, it affects the validity of self-reported data. So another comic for response bias, how can they say they are not biased against the government when they keep quoting them? So whenever you're doing research with controversial topics, you have to make sure that you make the participant comfortable and they tell the truth. So this can get quite tricky. Next we have measurement bias, occurs when the errors or inconsistency in the measurement tool or procedures used to study. For example, we have the instrument bias when measurement tools are flawed or inaccurate, procedure bias when there are inconsistency in how data is collected and what's the impact of it. Results can be invalid or unreliable. Next, we have confounding bias. Occurs when an outside factor related to confounding variables, so see how key terms interplay. Occurs when an outside factor is related to both the exposure and the outcome, leading to a distortion to perceived relationship between the two. Can lead to misleading conclusions about the relationship between variables. Next, we have publication bias. This tendency occurs for journals or researchers to publish positive or significant results. Because if we don't, then we fear that, oh, our entire study is down the drain, we've spent so many years on this. So that's why we tend to publish positive results. Impact, it can skew the literature and create a misleading representation of the evidence of a topic. A lot of famous researchers all over the world have been a victim of publication bias. So another comic here. I already wrote the paper. That's why it's so hard to get the right data. Next we have recall bias. Mostly appears during interviews, surveys or when you're collecting primary data. Occurs when participants do not remember past events or accurately or correctly, often due to passage of time or the nature of events. Can lead to inaccuracy in data collection. So this is it for now. Let's do some MCQs. So let's do some MCQs, and for MCQs I come to the Space Revision website because it will also tell us what is incorrect and what is correct and the explanation for the correct. So Research Aptitude, we just completed research process and we completed variables. So let's do some of the MCQs from there. Which of the following is not an example of continuous variable? Is not an example. That means we are looking at discrete variables. Number 1, family size. Family size is discrete because it always goes from 3, 4, 5. So this seems like the correct answer and the rest seems like continuous variables. So 1, perfect. A variable that has a causal impact on other variable is called, and we just did this in the video and you should be knowing the answer to this, independent variable. Dependent is the one that's caused an impact on. Confounding and extraneous are both extra variables that come up in the research study. So independent variable. An entrance examination with objective type question is conducted. For each correct 1 marks is awarded and for each incorrect answer 0.25 marks are deducted. The number of marks scored by an candidate who appeared in the examination is an example of. Nominal, no, because it contains actual value, marks. Even ordinal, no, because it's more than just ranks. So it can either be discrete variable or continuous variable. I feel it's continuous variable because fractions will be there, but also the fact that it's whole numbers, it's marks. So let's do continuous. This type can take on only values within a range. Yes, typically involve measurement. So why is it discrete? This type of variable specific in case marks are counted in whole numbers with the possibility of fractions, but they're still distinct and countable. Okay, that's why you take discrete variables. Alright, perfect. The systematic elimination of extraneous variables other than those you are interested in can be done in which of the following type of research? It is done in experimental research because we can control the variables. Longitudinal is mostly done through secondary research. Correlational research, also you still have those variables, you are not removing anything. And qualitative depends on what type of qualitative variable. So experimental. Perfect. Given below are two statements. A dependent variable can be dichotomous. Yes, it can be. Logic regression, probit regression are examples of it. An independent variable can never. Oh, this is incorrect. We have multiple regressions. We have again yes, no, marital status. These are all dichotomous variables. So statement 1 is true, but statement 2 is false. Perfect. Oh, we completed. Let's do some from scales in research. Which of the following technique commonality is associated? I think I did not teach you factor analysis, so let's just quickly look at what it means. Factor analysis is a statistical technique used to identify pattern in data and understand the underlying structure or relationship among variables. Okay, pattern in data and underlying structure. So the keywords that you have to remember. So the following for commonality is factor analysis. So for these you just need to know the key terms and the definition, so you'll be able to answer these. Not something which is tricky or I can teach you. So it's factor analysis. Perfect. We use factor analysis to know the relationship between two variables, to test the hypothesis, to know the difference between two variables, to know the difference among. Factor analysis or ANOVA is mostly used to know the difference among many variables. So D. Perfect. Alright, now let's do some MCQs from software. Identify the bibliographic softwares among the following. Like I told you, a very trendy topic. It had come in 6th December shift to 2023. So softwares that help us do reference management. So Turnitin is used for plagiarism. So A is definitely incorrect. EndNote, yes, it helps in reference manager. Reference manager, yes, and Mendeley. So B, C, D is the correct answer. Given below are two statements. SPSS is an open source software for data analysis. And Turnitin is very useful. No, it is not open source because we have to buy the software. So 1 is incorrect. Turnitin is a very useful software for. No, Turnitin is used for plagiarism detection. So both the statements are incorrect. 2. Perfect. So some of these you can do it on your own. I guess you got an idea. So what I've done for notes is given you exactly what's required for your NET paper 1 without giving you too much extra information so that it's overload, because I understand you have to study paper 2 as well. So for notes, flashcards and MCQs, you can go to spacerevision.com.